Okay, so we're going to look into the quadratic residues of these two numbers. And as we know, if x squared congruent with a mod n, i.e. n will be one of these numbers, exists, then those numbers a are the quadratic residues. Then after that, we're going to use these two boxes to see if we can form sets from these with these rules. For A00, quadratic residue follows a quadratic residue. Quadratic residue follows a quadratic non-residue, i.e. if this number doesn't yield a solution, and then non-residue, non-residue, and then non-residue to residue. So that covers all the possible bases for every number in the set. Okay, so first of all, n is 11. Well, we can see for n is 11, which is also a prime number, 11 congruent with 3 mod 4. That is the correct table for us with regards to 11. So let's just write here now the numbers for 11. So, quick way of finding the residues of this, we do 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and then stop at 6 squared because it's halfway or beyond 11. So 1 squared we know will yield a 1, that's fine. 2 squared will yield a 4, and 3 squared will yield a 9. So straight away there are residues, and square numbers are always quadratic residues that when the square is less than the modulus number. So that's a good start. Now 4 squared, that gives us 16, but 16 is not invited in modulus 11, so that becomes 5. So 16 is congruent with 5. 5 squared is 25. Again, modulus 11, that yields a 4. A 3. 25 congruent with 3 mod 11. And 6 squared yields 36. 36 mod 11, that also yields a 3. Okay, so there's our residues. 1, 3, 4, 5, 9. Okay, so now let's find the residues with 13. So for 13, straight away, we know we don't need to look at the first 3 square numbers. So we know 1, 4 and 9 are in straight away, so that's 1 squared, 2 squared, 3 squared. So now all we're interested in now is the 4 squared, 5 squared, 6 squared, 7 squared. Okay, 4 squared yields 16. 16 now modulus 13, that yields a 3. 5 squared 25, mod 13, that yields a 12. 6 squared 36, that yields a 10, modulus 13. And 7 squared is 49. 49 modulus 13 yields a 10 again. Okay, so now we've got 1, 3, 4, 9, 10 and 12. So that's our quadratic residues for the two numbers. Okay, so if A equals any of these numbers modulus these numbers, then a solution for that equation exists. Okay, now we want to look at these boxes and see if they fit our pattern. And also as well, with these boxes, it should give us some idea to the pattern we're doing and tell us if we've done these quadratic residues correctly. So let's have a look at 11 first. And now we're going to build a setup of A00 for n equals 11. So we'll just go down here. So this set will be the ones that we've got a quadratic residue following a quadratic residue. And the A00 in this formula is p minus 3 over 4. Well, 11 minus 3 over 4 gives us 2. There should only be 2 numbers then in this set. Okay, so 3 follows 4, and then 4 follows 5. So, sorry, 3 then precedes 4, and 4 precedes 5, so that would mean then that 3 and 4 are in this set here, which is as we was hoping from this formula. Now let's have a look at the A01. So A01 is this one here. So 11 plus 1 is 12, over 4 is 3. So there should be 3 numbers in this set. So we're looking for a residue which follows a which is preceded by a non-residue. So 1 is followed by 2, so that's good. So 1 is in there. 3, 4, 5, well they're all residues. So 5 is then up to 6, so that's 5. And then 9 is with next to 10, so then we got 9 to go in there. Okay, what about A10? Make that A look a little bit more like an A. Okay, A10 is non-residue followed by a residue. So a non-residue is 2, so that follows with 3 after it. So therefore 2 is invited into the set. And then 3, 4, 5 are residues. 6 is going to be followed a bit next to 7, and then 8. So 8 is a non-residue, which is then following with 9. So therefore 8 is in this set. Okay, and now A11, the last set to find. So 11 should give us 2 members of this set, 2 elements. So 11 is non-residue to non-residue. So 1, 2, 3, so that's not going to work. So 6 and then 7, so 6 is good. And then 7, then 8, so 7. So that follows this pattern here. And now let's look for 13, A00. Okay, A00 for 13. 13 is congruent with 1 mod 4, so now we're following the rules of this box. 13 minus 5 is 8 over 4, that gives us 2. So there should be 2 members of this set. So residue followed by residue. So 3 and then 4. So that's a 3. 4, 9, 9 and 10. 9 and 10 are together, so then that gives us 9. So there's our 2 elements for this set. Okay, let's now have a look at A01. So 13 minus 1 is 12 over 4. There should be 3 elements in this set. And 01 is a residue with a non-residue. So yeah, 1 and then to 2. So 1 is a member of this set. 3, 4, 4 and then to 5. So 4 is a member of this set. 9, 10, 10 and then to 11. So 10 is a member of the set. Okay, so now we're looking at elements for this set, non-residue followed by residue. So a non-residue here would be 2, which is then followed by 3, which is a residue. So 2 is a member of the set. 4, 5, 6, 7, 8 is a non-residue, followed by 9, so that's a member of the set, is 8. And then non-residue is 11, which is followed by a residue. So that gives us our 3 elements of this set. And then finally, A11, elements of this set are non-residue to non-residue. So 1, 2, 3, 4, so 5 goes to 6. So 5 is a member, 6 then to 7, and then 7 on to 8. So that's our elements